Alright, in this video we'll be looking at the stationary points question, which falls under differentiation. Now this question is pretty repetitive, so I'm not going to do 3 questions, I will do 2 instead. So we're going to do the first 2 questions together, and then you can download the worksheet and do the rest of the questions by yourself. If you get stuck, go to the answers section and see where you went wrong. Let's get into it. Number 1. At the point 4, minus 1 on a curve, the gradient of the curve is negative 3 over 2. It is given that dy dx is equal to x to the minus half plus k, where k is a constant. Show that k is equal to negative 2. Alright, so we've been told that at the point 4, negative 1, the gradient dy dx is equal to negative 3 over 2. So we can use that information to substitute into this equation over here. We're saying dy dx is negative 3 over 2 and x is 4. So that's 4 to the negative half plus k. So this is negative 3 over 2 is equal to, that's 4 to the power negative half. And that gives us 1 over 2 plus k. So that means k is equal to negative 3 over 2, negative 1 over 2. So k is in fact equal to negative 2. So that's part A. Part B, it is given that the equation of the curve is y equals 2 root x minus 2x plus 3. Part B, find the coordinates of the stationary point. Okay, so we now know that dy dx is equal to x to the power minus half plus k, or k is negative 2, so we can substitute k here with negative 2. And we want the coordinates of the stationary point, so we can simply equate our gradient function to 0. X to the minus half minus 2 is equal to 0. I'll just write that as a positive power, so that's 1 over x to the half minus 2 is equal to 0. So 1 over x to the half is equal to 2, which means that x to the half is equal to 1 over 2. And let's square both sides. You get x is equal to 1 over 4. So we know that the x coordinate of our stationary point is 1 over 4. Now let's find the y coordinate of our stationary point. To do that, we have to use the equation of the curve that we have been given over here. So y is 2 root x minus 2x plus 3. Y is 2 root x minus 2x plus 3. We can substitute x as a quarter. So y is equal to 2 root 1 over 4 minus 2 times 1 over 4 plus 3. And let's simplify this. Punch this into the calculator. This is 2 root 1 over 4 minus 2 times 1 over 4 plus 3. That gives us 7 over 2. So that means that the coordinates of the stationary point are 1 over 4, 7 over 2. Let's check if this is correct. This is question number 1, part B. Part B, our coordinates are in fact 1 over 4, 7 over 2. So that's correct. Let's do part C. Part C says determine the nature of the stationary point. So to be able to determine the nature of a stationary point, we need to find the second derivative. So our dy dx is equal to x to the negative half minus 2. Let me just verify if that's correct. Yes, it's correct. So we need to find d squared y dx squared, which is our second derivative. So let's bring down our power, negative half, x, subtract 1 from the power, that becomes negative 3 over 2. Then the constant will become 0. So now we want to determine the nature of the stationary point at x is equal to 1 over 4. So let's substitute that dx squared into our second derivative. That's 1 over 4 to the negative 3 over 2 punch this into the calculator. This is negative 1 over 2 times 1 over 4 to the power negative 3 over 2, and this gives us a negative 4. So we can conclude that at x is equal to 1 over 4, our second derivative d squared y dx squared is equal to negative 4, which is less than 0. Hence, it is a maximum point. And we can check if our conclusion is correct. This is 1 part C. The second derivative is negative, therefore our point is a maximum point, correct? Alright, so let's erase this and then we'll do the second question. Alright, so let's look at question number 2. The equation of a curve is y is equal to 54x minus 2x minus 7 to the power 3. Part A, find dy dx and d squared y dx squared. Okay, so we're given the equation y is equal to 54x minus 2x minus 7 cubed. So let's start by finding our first derivative, dy dx. This becomes 54 minus, let's bring down our power, 3 times 2x minus 7. This is to the power 3 minus 1, so 2, multiplied by the inner derivative, which is 2. So dy dx is equal to 54 minus 3 times 2, that's minus 6, times 2x minus 7 to the power 2. This is our first derivative. Let's go on to find the second derivative, d squared y dx squared. So this constant would become 0. So we've got negative 6, bring down the power 2, times 2x minus 7. Our power becomes 1, and then multiplied by the inner derivative, which is 2. So d squared y over dx squared is equal to negative 6 times 2, which is negative 12, times 2, which is negative 24. So negative 24 times 2x minus 7. Okay, so let's check if our two solutions are correct for dy dx and d squared y dx squared. This is number 2, part A. We've got dy dx is 54 minus 6 times 2x minus 7 squared, and d squared y dx squared is negative 24 times 2x minus 7. That is correct. Alright, let's do part B. Part B says find the coordinates of each of the stationary points on the curve. So we know that at a stationary point dy dx is equal to 0. So we can equate our gradient function dy dx to 0. So that's 54 minus 6 times 2x minus 7 squared is equal to 0. Now notice how this is in a completed square form. So we can solve this quadratic using the completed square form method. So this becomes 6 times 2x minus 7 squared is equal to 54. Divide both sides by 6. 2x minus 7 squared is equal to 9. Take the square root of both sides. So that's square root here, square root plus or minus. So 2x minus 7 is equal to plus or minus 3. 2x is equal to 7 plus or minus 3. And you get x is equal to 7 plus or minus 3 over 2. And this results in our first solution, 7 minus 3, that's 4 over 2, so that's 2. And then 7 plus 3, 10 over 2, that is 5. Alright, so these are the x coordinates for our stationary points. We need to evaluate the y coordinates. For that, we need the equation of the curve, y equals 54x minus 2x minus 7 cubed. Alright, so y is equal to 54x minus 2x minus 7 cubed. So let's evaluate at x is equal to 2. Y is equal to 54 times 2 minus 2 times 2 minus 7 cubed y is equal to, let's punch this into the calculator, 54 times 2 minus 2 times 2 minus 7, and this is cubed, that's 135. And then let's evaluate at x is equal to 5, so y is equal to 54 times 5 minus 2 times 5 minus 7 cubed. Punch this into the calculator, that is 54 times 5 minus 2 times 5 minus 7 cubed, and this gives us 243. And so we can conclude that the coordinates of the stationary points are 2, 135 and 5, 243. Let's check our answers to see if this is correct. This is number 2, part B, 2, 135 and 5, 243. That is correct. Part C says, determine the nature of each of the stationary points. So in part A, we already evaluated our second derivative, which is negative 24 times 2x minus 7. So I'm just going to copy that at the bottom. D squared y dx squared is equal to negative 24 2x minus 7. Now let's start by evaluating at x is equal to 2. At x is equal to 2, d squared y dx squared is equal to negative 24 times 2 times 2 minus 7, and this gives us d squared y dx squared is equal to, punch this into the calculator, negative 24 times 2 times 2 minus 7, this gives 72. Alright, and now let's evaluate at x is equal to 5. So d squared y dx squared is equal to negative 24 2 times 5 minus 7. D squared y dx squared is equal to, this is negative 24 times 2 times 5 minus 7 is equal to negative 72. So we can conclude that at x is equal to 2, our second derivative d squared y dx squared is equal to 72, which is greater than 0. So hence this is a minimum point. And then at x is equal to 5, our second derivative d squared y dx squared is equal to negative 72, which is less than 0, hence maximum point. And we can check if this is correct. This is x is 2 is a minimum point, x is 5 is a maximum point. Let's see. X is 2 is a minimum point, x is 5 is in fact a maximum point. Alright, so that's our 2 questions for this video. Make sure to download the worksheet and go through the rest of the questions by yourself. If you get stuck, make sure to check the answers section. Otherwise, thank you for watching the video. I hope you found it useful. See you in the next one.